Um, yeah, I had the same talk in Rust Fest, which happened in Barcelona just a few days ago. But it's kind of relevant to Linux desktop in general, a bit to apps, because apps use ZBus to connect to services and stuff. And you will probably use this API that I'm talking about if you're developing an app, any app for Linux desktop. First of all, who am I? Well, my name is Zeeshan Ali, work for Red Hat, but my job is in the cloud stuff, cloud infrastructure stuff, so all this that I'm talking about is my spare time stuff right now. I work with FOSS, been doing GNOME stuff and other FOSS related things for a long time, and I like flying, and I have a cat, and I like cats. So the background story for this talk, I have a project called GeoClue. It's a component of the Linux desktop, which tells you where you are. Well, it doesn't tell you directly, but the apps use this service to ask where you are, and it uses different sources to find that out. It's like, as I said, you're looking service, and it's written in C. I've been the maintainer since GeoClue 2. It was a complete rewrite with a lot of different ideas, and that was 2013 or 14, so it's been many years. But I had an idea this year, beginning of this year or last year, that let's oxidize it, which means to convert it to Rust from C. But why? You ask. Well, first of all, it's in C. I have a lot of experience with C programming. I'm really comfortable writing C, but I'm a human being. I make mistakes, and that means that there's crash reports, like memory problems every now and then. Even if I use like tools that help me with that, there will still be mistakes, because C is a language that makes it very easy to make mistakes. And also, like, location is one of the most sensitive data about a user you can have. So if you have memory issues, it can be, you can use that. Attacker can use that to get your location information, and we don't want that. And most importantly, I love Rust. It's a language that I've been looking for a very long time, an efficient language that is also safe by design. But before I go oxidize GeoClue, there are some challenges. First of all, that I was most worried about was the build system. A lot of the desktop and embedded services nowadays, they use Mason, which is a build system and configuration and build system, however you call it. And that has support for Rust, but it doesn't have support for Cargo, which is the build system that is used with Rust everywhere. And support for Rust without support for Cargo is not very useful in the end. You really want to use Cargo if you're doing Rust projects, unless it's a very simple stuff, and then you can just use Mason directly. And the other challenge was ZBus, the interprocess, which is a very efficient interprocess communication protocol used on the desktop. I don't know if I need to tell this audience what that is, but just for yeah, it's very famous in not just in desktop world, but also in embedded world. It's used a lot for IPC. There was a ZBus library for Rust. It is not was, and it's using ZBus, libdbus, which is a C library. So all the actual work is happening in an unsafe language, and that was my whole point, to do things in a safe language, especially things that handle interprocess communication and stuff. That would be very nice to have it in a safe language, all of it. But still, I thought, like, even though it has not just that issue but many other issues, I still decided to use it, and not just use it, but also I contributed at first, and I thought, like, yeah, I can really use that library. But then in May we had a Rust GNOME Hackfest, and I decided to actually started porting GeoClue, and I realized that the Mason bit that I was afraid of is very easy to work around with, and the main problem that happened was the ZBus RS API was really overcomplicated, especially the parts that I needed. They were really hard to decipher even how to use it. So I was like, what should I do? I tried, like, I spent like a day or two just trying to decipher how to use that API. And I was like, maybe I should just rewrite my own ZBus crate, and it's like from scratch, not using libdbus, so that the API is nicer and not just for me, but for others as well. And this idea has been around, like quite a few people are, I realized later, that have tried creating a ZBus library from scratch in Rust, but they lost interest at some point, all of them. And I was like, how hard can it be? I really wanted an answer to that. No, it wasn't just like, nah, it can't be hard. So I looked into the ZBus spec and to see what's involved and to decide if I can do it or not. So on the low level, it's just a message passing protocol, and it's it doesn't matter what transport mechanism you use. You can even do it on TCP, but of course it's not secure. Usually, typically on desktops, you do it through Unix sockets, local Unix sockets, which is specific to your domain or your user. So you can have some kind of security there. And it has, on a low level, a wire protocol, which is kind of also known as GVariant, because when it was created, glib was one of the first users of it, and they created this API called GVariant, which is basically the ZBus wire protocol, and you can use it outside of ZBus context as well, and a lot of people do that. So yeah, I looked into that, and it's basically a bunch of data types and their encodings. That's what the spec defines, and they have a natural alignment. And so if you have like a 4-byte integer, it's aligned on a 4-byte address. So mostly it's very natural, and it seems logical. And each data type you have that spec defines has something called signature, which is a string that defines what the data is. Every simple type has a one letter, of course, and then you create the container data types by combining the container's signature and the contained type signature. And the basic types actually map quite nicely to the Rust basic data types. These are actually examples of Rust data types, and the ZBus data types are exactly the same. So that's easy. Containers, it's a bit complicated. Array is, just in Rust we have a data type called vector. It maps nicely to we also have an array, but vector is most used because it's dynamically allocated, and it can grow and shrink dynamically. And structure is like just like a struct in C or Rust or many programming languages. You have a bunch of data that is put together. So that's also easy, not so difficult. And then dictionary is also like it's in Rust. In the standard library there's a data type called hash map, and in other programming languages you have something similar, some dictionary or hash map, and it maps nicely there. And we have a bit difficult one, we will see later. It's called variant data type, which is a generic data type in Rust, in ZBus, and which means it's you have the signature of the data that you have inside and the actual data in there. So you can put any kind of data in this variant. So if you want to transfer it in a any data in a generic way, you put it in a variant. So that's the low level. It seems pretty simple, right? And high level, you have objects. When you connect to a service, you talk to a specific object or objects in that service that it exposes. These are the ones for GeoClue that you talk to, and these objects implement something called interfaces. It's very similar to interface concept in programming languages. And the API you have is on the interfaces. And basic API is methods, and signal. Signal is just a method, but in the other direction, that you get an event from the service in terms of signal. And method is something usually an app calls on the service. And properties, like these can be read-only or read-write as well. And these are all on interfaces, and objects implement those interfaces, and they have the APIs then. So I looked at all this and I was like, this doesn't seem that difficult as I thought it would be. So let's give it a shot. So while I was at the Hackfest and a few days after, I had like 3 days, and I started putting something together. And after 3 days, I was able to establish a connection, and I was able to call a method, like a simple method, but still able to successfully call it and parse the return value and stuff. So I was like, cool, let's really do this, because it doesn't seem that difficult. So that's when I created this project called ZBus, which is just a Rust crate for doing dbus. So I was like, let's start with the simple part, like not simple, but the basic part, the low-level bit. And if I get that right, then the high-level stuff should be easy. So I came up with this trait. Anyone knows what is a trait in Rust? Can you raise your hands if you know? Okay, most people don't know. Sorry. So trait is like an interface in many like object-oriented programming languages. You define your API in that trait, and then any data type can implement that trait, and then it has to provide all the API in that trait. So this is like a trait for anything that can be encoded and decoded into DBus wire format. So as you can see, it has like signature, any type that you claims that it can go on DBus. It has to provide like what's its signature, what's the alignment, what's the it has to provide a method to encode it. It has to provide a method to decode it. Don't bother with extract slice. It's too much to explain right now. And of course the signature, the last method, which is the signature, is actually for simple types it will be the same as the constant that you have, because they just have one letter. But for complex types it would the method would return something that has the signature of the contained types as well, not just the container. So I started to implement this trait on simple basic types, which was super easy, and then container types. As I said, we have a vector. Vector can have something called generics in Rust. If you want to define something very generic, you can use these generic parameters, but you can have bounds on these generic parameters. So for example here, a vec in the standard library is already defined as something that can keep any kind of data in it. But I in here add a constraint on it that for this one it has to be a variant type, something that can be encoded to DBus as well, the contained type. And then the rest is just putting it together. Structure, it doesn't map exactly to the struct in Rust, but the thing is that's more static, and what we need to send on DBus, we need to prepare and put together, is more dynamic. So I needed a separate API, so I had to create a separate data type and methods on that data type to create it and to parse it. And then of course the variant type trait was implemented on it. And then the variant bit, which is, as I said, it keeps a signature of what is contained inside, and it keeps the actual encoded value inside it, which is why I thought it's a good idea, but later it turns out it's not. And this is the API in use. It's my unit test. You can create since I64 type implements variant type, it can be put in a variant, and Yeah, basic stuff like you encode it and you can then decode it. Can I do this? Yeah. Yeah, this is decoding from raw data, and yeah, you get the same thing again back. So, but the thing is, I lied before in my previous slide. The trait that I showed is not as simple as it looked. It had to have something called lifetimes. In Rust, you use lifetime parameters to tell the compiler what is the lifetimes of the parameters and the return value, and you associate the lifetimes of the parameters passed to a function to the return value, and also like you define lifetimes on the inner value of structs. Yeah, so with lifetime it looks like this. I'm not a fan of lifetime syntax in Rust either, but it's just a syntax. This makes things a bit harder, although I was going for efficiency, and lifetimes was the only way to keep things efficient, so that I don't have to copy data. I can just say, okay, whatever is passed to decoder, the slice of data, that's lifetime is the same as when you slice it, and also the when you return something from the decoder, so it has the same lifetime. Which worked well for a bit, but I ran into a lot of problems. Each time I change anything in the API in any way, lifetimes comes on the way, and I have to make sure that they are all okay. If you haven't played with Rust and ever, it's very strict language. That's the strength of it, and also a bit of a problem when you first start coding in Rust. The compiler complains a lot about everything, and you hate yourself. But when you get it to compile, then your code works just fine. Like you don't have to debug anything. So that feeling is worth the trouble. So yeah, but in this case, I had too much trouble, and I don't think that feeling was worth it. So back to ZBus, right? How does it look for ZBus? I have only basic stuff on the high level implemented, like establishing a connection and calling a method based on the variants that I have defined. When you have a connection, you just say which service you want to use, which objects you want to operate on, and what's the interface name, and then the method name, and you can pass parameters. And this is a simple case, so there's no parameters to pass. And then you get a reply, and you can parse the reply body as a variant, and then you can, if you should know the type of what you are expecting. So you say, I want the data, and you give it the type, exact type, and you get the exact data of that type, and then you can do whatever you want with it. And I was like, okay, I can use I have defined all the variants. I have created for all the data types that are in ZBus, and I can call methods with it and stuff. So I was like, well, maybe I'm done now. It's all done, and hoping to put the variant in a separate crate, first document it and stuff. But then I realized something. I added, the last data type I added was the hash map, and the test cases that I added were a bit extensive. So they were failing, and I thought maybe I have made some mistake in the implementation or the test cases themselves. I was looking at it for days, and I realized that no, that wasn't it. It was like something much worse. Variant alignment was all wrong that I had implemented, and that only came out in that test case. Turns out ZBus has a strange few rules. It's not all great. The first rule is alignment is based on the position in the message. So if you have a message and you're putting different data in it, the alignment of that each data is based on what's its position in the whole message, not just the container what it's in, which is fine. It's not a big problem. It's easy to solve. But as I showed you in the beginning, the encode method and decode method they don't take care of this. You just give it, you just tell it like, yeah, encode yourself, and you get the bytes. You don't get the padding for the alignment. But this is easy to solve. You just add another parameter, which I did later on, and tell it like these many bytes are before you, and it aligns itself based on that. But then there is another rule, variant and the contain value. The variant data type I mentioned, the generic one, it does not need any alignment for itself and for the data that it contains. However, its grandchildren do. So if you have like a hash map inside variant, then the variant and the hash map does not need alignment, but the keys and the values in it do need an alignment, and that makes things really difficult, because you have to then pass the whole information to the encoding in there, that, oh, you are inside, you shouldn't be aligning yourself, but you should be only aligning your children. So yeah, and that the current API doesn't take care of that. So this was 1 month ago about that I came across this issue, and I still haven't fully solved it. And the main reason is that lifetimes are hell to work with. I've learned a lesson through this whole thing, and that is that efficiency is not a religion. You shouldn't take it so religiously. And I realized that what I was doing, I got went overboard with efficiency. So the compromises that I'll make in C, that I'll be fine with doing in C, I was not okay with doing the same in Rust, because I was trying to make it so efficient. Like, it's not worth it. There's APIs that you can use to share data between different parts of the code safely. They are not as efficient as if you would just pass pointers around, but they are not so inefficient after all. Actually, they are more efficient than when you would do it in C. For example, in C, in GeoClue, I use something called GObjects, and GObjects are reference counted by the default. And that reference counting, because the C API does not know if you will be using it in a multi-threaded environment or not. So the reference counting is atomic by default, and that's not cheap. If it depends on how many objects you have, of course, but if you have a lot of objects, and it can be quite inefficient to have it atomic. But Rust has different data types for using in a single thread and multi-threaded environment. It's called RC, it's called reference counted type. It's just a container type. You can put your data in it, and then you can share it around in your code. And it's not atomic, so it's pretty efficient. It's more efficient than I'll do it in C when I do it in C. First of all, I need to solve this problem. But before I solve this problem, I have to kill the lifetimes and do it slightly inefficiently, but make the code a lot more easier to change. And so after that, once I'm done with that, I want to put the variant crate separately. As I said, people use this G variants and the wire format outside of ZBus context as well, so they can use it for that. Then, of course, simple things that are ZBus related, receiving messages. I only can send right now signals, which is pretty trivial once you have the sending and receiving messages. And asynchronous API. So I want to have my API very asynchronous because it's I/O, of course. So you want it not to block the threads and stuff. So far in Rust world, the async story was a bit in a limbo, but recently it got all stable. Like there's these stable APIs for doing async, and there is now a stable library called async std, which is the same as a standard library, but async version of that. And it looks really cool, and I'm really looking forward to using that to provide async APIs. And then once I have the low-level stuff done, high-level should be trivial. And of course, code generation. Everyone I know that uses ZBus usually use code generation to deal with ZBus. There are some communities where that's what they always tell you. Like if you have any problem with DBus, to directly handling DBus, they will say, why are you not using code generation? So it's taken kind of for granted. So I need to provide that. And also maybe macros. Rust has really powerful macro system. You can do a lot with it. And some things can be simpler if I provide macros for those things to handle. And a lot of these things are easy stuff that I need to do. So that's it from me.
We have like 2 minutes for questions. So does anybody have a question? No? Come on. No? Not really?
Okay.
Okay.
Wait. Are you sure?
Probably. Isn't there... maybe I'm wrong. Isn't there already a G variant, like the thing in GTKRS used?
Yeah, but that's in glib. It's
Yeah.
it's a C library again.
Yeah, I
so
know.
C.
You don't want.
No, I want a pure Rust for safe. Like I want to have safe code for dealing with DBus.
Okay.
And as I said, like actually at C, it will be more inefficient code that I'll be using. So I want it even efficient.
Thank you for the talk. Is this something that can be built reproducibly? I appreciate you using Cargo, and so in my experience that pulls in the latest and greatest of everything every time you build, and it makes it hard to do reproducible builds.
You mean like a lot of projects, they are using unstable? No, at least right now, I'm not using a lot of dependencies anyway. Like there are only 3 dependencies, and they are all stable. And I thought like I'll have to use the unstable async stuff, but now it got stabilized, so I don't need to, even for that, I don't need to use any unstable stuff. Yeah.
So I'm going to do the nice thing and answer instead of ask. With Cargo, one thing you can do, so the idea is the semantic versioning, so you have major, minor, patch level. You can specify your dependency as only major or major and minor or down to the patch level, which then pins to the varying degrees of I want reproducible or I want latest and greatest. And next to the cargo.toml thingy they use for configuration, there's also a cargo.log that gets generated. And I'm not quite sure how it works. Usually it gets overridden, but there's some mechanism to actually lock that down. And then you could basically, as distribution, say, keep this state around, and the next time I want to rebuild, use exactly those versions you got at that point in time. So Cargo has support for it, but I think most projects just go with major, maybe minor, but patch level just get the latest and greatest.
Yeah,
that's more using like the upstream what they want than a problem with Cargo.
Yeah, but even with if you specify a version, even if it's you just specify I'm sticking to this major version, still it will get only the releases. Like it would download the release version, not from the Git master, unless you say it like I want Git master of this dependency.
Okay, we're out of time for questions, so thank you again.